Welcome back. So we have made it to day 3 of 4.3 part 2. So we're going to split up this day into 2 parts. First part, we're going to focus on equations, and then we're going to focus on word problems for part 2, or the second video. First thing I want you to do, on the top of your lesson agenda, warm up for day number 3. We're writing an equation of the line that passes through the point -3, 6, and 1, -2. Now it just says write an equation. I actually want us to practice writing it in slope-intercept form then as well. So once you find the equation, convert it to slope-intercept form. You're going to pause the video while you do that, and then hit play to go over the answer with me. All right, at this point we should be done. Let's go over the answer together. So the first step, hopefully you did this, x1, y1, x2, y2. Label your point. We need to know the slope for either form, so I'm going to find the slope using the formula y2 minus y1 over x2 minus x1. From there, plug our values in. So -2 minus 6 over 1 minus -3, which is going to become a positive because it's a double negative. So that's -8 over 4, which is -2 if we reduce. So there's our slope. I now know at least one point, and I know the slope. So I'm going to use point-slope form. So that's y minus y1 equals m times x minus x1. Now at this point, if you're good enough, if you're comfortable enough with this formula that you want to, oh, by the way, I'm going to use this point. If you want to just jump right into it and you don't need to write out the formula first, go for it. But that's all up to you and what you're comfortable with. So y minus 6 equals -2 times x minus, and x1's a negative, so we're going to get a double negative again, which is +3. All right. Now at this point, I have an equation. If that's all the question asks for, then you're done. But I said I want you guys to write this in slope-intercept form. So our 2 steps, I'm going to distribute. So y minus 6 equals -2x minus 6. -2 times 3 is -6. And then I want to get rid of the constant with y to get y by itself. So I'm going to add, because that's the inverse operation of subtracting. And we get y equals -2x plus, wait a second, -6 plus 6. Oh, it's just 0. So really I can take that one step further. Y equals -2x. And there's our equation in slope-intercept form. So today we are talking about the third form of a linear equation, and that is standard form. Now, typically, this is one that we will use the least. We prefer point slope or slope intercept. It's just easier. But you will see it in this form. You might have to convert to or from this form, so it's beneficial to know. You might especially have to convert from this form. So let's talk about it. X and y are always together on the same side. So notice when we look at this equation, x and y are both on the left side of this equal sign. A must be positive. When they say A, they're talking about this coefficient here. The coefficient in front of x is what we call A in the formula. That has to be positive. The values of A, B, and C, so all of these coefficients and the constant, all have to be integers. Now, what is an integer, you might ask? Well, an integer is a positive or negative whole number or 0. So that could be like -3, -2, -1, 0, 1, 2, 3. Numbers just like that. So they have to be integers, but A has to be positive. So A has to be a positive integer. You can't have fractions, you can't have decimals because they're integers. To get rid of or clear fractions, we've talked about this before. We might need a refresher. We want to multiply each term in the equation by the least common denominator. So this takes us back to, what is that, learning target number 4 when we talked about least common multiple. We want to find the least common multiple of the denominators and multiply everything by that number. That's how you get rid of fractions. If you want to get rid of decimals, you multiply each term in the equation by a power of 10. Multiplying by powers of 10 just moves the decimal place one place to the right for every power of 10. Don't worry, don't sweat it. We're going to do some examples to show you what that looks like tangibly. So, for example 1, we want to write the equation in standard form. So, a couple of things. Number 1, x and y have to be on the same side. So, because the constant has to be on the other side, I'm actually going to move this x over there. All right. Now, to do that, I need to do inverse operations. So, this is a positive 2/5 x. I want to subtract 2/5 x. For those of you that need this, right, we can draw a line through that equal sign just so you're comfortable with what the left side is and what the right side is. So those cancel. That leaves us with negative 2/5 x plus y equals, and that's a negative 3. Now that is still not in standard form because we can't have fractions. And this leading coefficient here also can't be negative. So we're going to kill 2 birds with 1 stone here. To get rid of fractions, we want to multiply all of the terms by the least common denominator. Well, there is only one denominator because this is the only fraction. So we're going to multiply all of them, every single term, by 5. Now, not just 5, I want to make this positive. So I'm going to multiply by a negative. Negative times a negative will make that positive. So we're going to multiply by negative 5 times everything on both sides. So negative 5 times negative 2/5, that's going to give us just 2. The denominators are going to cancel. Positive 2x. Negative 5 times y is negative 5y. And on the right side, negative times negative gives us positive 15. And we're done. We have all integers, 2, negative 5, and 15. And our leading term with x is positive, and x and y are on the same side. We've checked off all of the boxes. It's in standard form. Now let's try one that has decimals to see what that looks like. So first step, we want to get x and y on the same side. Now for this one, I'm actually going to move x again. And here's why. It's negative over here. So if I move it to the other side, it's going to make it positive. So that's 2.2 equals, I'm going to put the x first because that's what the form looks like, x plus 0.1 y. Now, you might be asking at this point or thinking in your head, wait, Mr. Hollinger, why are x and y on the right side? I thought x and y are on the left side in standard form. Well, you're correct. Here, we show x and y on the left side. But let's think about equations for a second. Separate thought. Is 2 equals 3 the same thing as 3 equals 2? Are they the same? Yeah, they are. It's just like saying my age is 28 or 28 is my age. It's just a different way, a different order of saying it. It's still the same statement though. So it doesn't matter if x and y are on the right side or if x and y are together on the left side. They just have to be together on the same side. So for those of you that you just really don't like that, and it really is messing with your brain, just flip the side. So put the x plus 0.1 y on the left equals 2.2. You can do that because equations are commutative. You can change which side of the equation it's on as long as you flip-flop everything. All right. Still not in standard form. The issue is the decimals. Because our leading coefficient, hey, that's positive in front of x. But we have some decimals here. So there's only one decimal place. So we just need to move the decimal one place to the right, and then we're good. So we're going to multiply by 10. Every multiple of 10 moves the decimal place one place to the right. So if I multiply by 100, that's got 2 zeros behind it, we're going to move the decimal place twice. We just need to multiply by 10. So multiply by 10 on both sides. When we distribute, and yes, you have to multiply all of them, not just the ones that are decimals, we get 10 times x, which is 10x, and 0.1 times 10, which is just 1. Again, all we're doing is taking that decimal, moving it one place to the right. Then on the right side, 10 times 2.2, all we're doing is taking that decimal, moving it one place to the right. So that would be 22. 10x plus 1y equals 22. Example 2. We want to write the equation in standard form. We can't write it directly into standard form, but we can write an equation and then convert it to standard form. So that's what we're going to do. We have a point, we have a slope. I'm going to label that point and the slope, and I'm going to use point-slope form. Y minus, my y1 coordinate is 1, equals slope 3/4 times x minus, my x1 coordinate is a -5. I get a double negative, so this becomes positive. Now I want it in slope standard form. So first thing I need to do is I need to distribute the slope to both terms. So y minus 1 equals 3/4 x plus, and this is 15/4. How do I know that? Write 5 as a fraction, multiply the numerators, multiply the denominators. 3 times 5 is 15, 4 times 1 is 4. Now I need to get x and y on the same side and the constants on the other side. So I'm going to move, let's see, I'm going to move the constant plus 1, y equals 3/4 x plus, well, 1 is just 4/4. So I'm really adding 4/4 to 15/4, so that's 19/4. Now, this is slope-intercept. I want standard form. I need to move the x and the y to the same side. So I am going to, let's see, I'm going to keep x positive. So I'm going to move y. That gives me 0. 3/4 x minus y plus 19/4. I can't combine any of these because this is a constant, this has y, and this has x. They're not like terms. And now I just need to get rid of this constant term. So I'm going to do the inverse operation, which is subtracting 19/4. Subtract 19/4. And that gives me 0 minus 19/4, negative 19/4 equals 3/4 x minus y. Is it in standard form? Almost. We have x and y on the same side, but we don't have integers, we have some fractions. So I want to find what is the least common denominator. Fortunately for us, they have the same denominator of 4. So the least common denominator is 4. So I'm going to multiply everything on the left by 4 and everything on the right by 4. And yes, everything, whether it's a fraction or not. when I multiply on the left by 4, the denominators cancel, so that's just negative 19 equals, distribute 4 on the right, 3/4 times 4 is just 3, so that's 3x, and 4 times negative y equals negative 4y. That is in standard form. If you need to flip-flop that, just so you can see x and y on the left side, go for it. 3x minus 4y equals negative 19. That equation is in standard form. So this really just helps us practice getting comfortable with manipulating equations. The more comfortable we are with manipulating equations, the easier it will be for us to deal with equations that are in different forms than what we're hoping for them to be in. So your turn number 1, you are taking the point and the slope and writing an equation and converting that equation to standard form using the steps that we've outlined previously in our notes. Once you are done, so you're going to pause the video as you work on that. When you're done, hit play and we will go over the answers together. All right, at this point you should be done. I'm going to label my points. Hopefully you did that as well. Then you plugged this information into point slope form. So y minus y1 equals slope times x minus x1's negative 4. We got a double negative there, so it's plus 4. Distribute. Y minus 3 equals negative 2x minus 8. Add 3. Y equals negative 2x minus 5. This actually is a really easy problem because all you have to do is move that x over and it'll become positive. So we need to add 2x to both sides. Those cancel. We can't combine x and y, so that's 2x plus y equals negative 5. We don't have any fractions. We don't have any decimals. All of our coefficients are integers, and this leading coefficient is positive. So it's in standard form. Recall that equations of horizontal and vertical lines look something like this. A horizontal line has an equation where y is equal to some number. Why does this make sense? Because y is talking about the height up and down. So the height of a horizontal line is always the same. It's always, in this equation, up 2. So y is always equal to 2. Then, for a horizontal line, that's when our x value stays the same. So in this equation, x equals 4 is telling us that we're always right 4 on the x-axis. So it doesn't matter how far up or down that line we go, we're always right 4. So we get that vertical line. So for example 3, what we want to do is write the standard form of a horizontal line that goes through the point 3, negative 2. So here's a tip for you, a strategy. If you visualize this, it's going to make your life a lot easier. So I'm going to draw a little graph off to the side. So I got my x and y axis, and I want to plot the point 3, negative 2. So 3, negative 2, that's 1, 2, 3 to the right, and then 1, 2 down. So here's the point 3, negative 2, and it's a horizontal line going through that point. Horizontal is flat, so that would look like this. So now that I can visualize it, is my x-coordinate staying the same or my y-coordinate? Well, my height is always the same. It's down 2. So that's when y equals some number. Well, what is y equal to at that point? Negative 2. So that means that y is always equal to negative 2. because it's always down 2 on the y-axis for that horizontal line. For the second one, we are now writing the standard form of a vertical line, of a vertical line that goes to the point 3, -2. So again, we're starting off the same way. Coordinate plane, right 3, down 2, plot the point. But now it's a vertical line, so that's going to go straight up and down. Now what's staying the same is the x-coordinate. We're always right 3. So x is always going to be equal to 3. Again, if you draw a graph for these, it will make your life so much easier being able to visualize the line. So your turn number 2, very similar to what we just did. You're writing the standard form equation of a horizontal line through the point 0, 1, and then of a vertical line through the point 1, 0. Notice these points are not the same. The first one's 0, 1, then it goes through 1, 0. Once you are done with those, you're gonna pause the video as you work on that. Once you have those equations, go ahead and hit play, and we'll go over the answers together. All right, at this point you should be done. First thing hopefully you did was draw a graph. If I graph this, let's see, 0, 1 would be this point right here. We want a horizontal line. That should be the equation y equals 1. Our height is always up 1. For the second one, again, hopefully you drew a graph. 1, 0 is right 1, and we don't go up or down. We stay on that x-axis, so that's right here, 1, 0. And it's a vertical line, so that's straight up and down. So that is when x is always right. Oh, and look at that. Because I flipped this, I even tricked myself. That is not the answer. The answer should be x is always right 1, because the x-coordinate is 1. So x should equal 1. Got myself there. All right, your turn number 2. Now these are the same. I think maybe that was a typo that in the notes. Maybe I should have kept it the same. Horizontal line through the point -2, 0. Vertical line through the point -2, 0. Pause the video as you complete this. Make a graph to make your life easier, and then write the equation in standard form for both. When you're done, go ahead and hit play. We'll go over these last two together. All right, now that you are done, you should have a graph with a point at -2, 0, and a horizontal line going through that. That's interesting. If it's horizontal, it's actually on the x-axis. That would be when our height is 0, because our y-coordinate is 0. For the second one, draw the graph, -2, 0. Again, we are right on that x-axis. And it is now a vertical line, straight up and down. So that is when our x-coordinate is always left 2. So if we want a vertical line there, that's at x equals -2. Continue watching the rest of the notes. In the next video, we will talk about word problems.